Good morning, everybody. Thank you very much for your attendance. And now we have the presence of Professor Marco Liserre. We are celebrating the 31st anniversary of the electronics program in the Technological Institute of CELAYA. And we have a pleasure and honor to have here with us to Professor Marco Liserre, which will give a conference entitled, let me check it, the Smart Transformers, providing service to the electric network and addressing the reliability challenges through power routing. The Professor Marco Liserre received the Master Science and PhD degree in Electrical Engineering from the Bari Polytechnic, respectively in 1998 and 2002. He has been Associate Professor at Bari Polytechnic and from 2012, Professor in Reliable Power Electronics at Aalborg University, Denmark. From 2013, he is full professor and he holds the Chair of Power Electronics at KIEL University, Germany. He has published 500 technical papers and a book. This work have received more than 1,000 citations, and Marco Liserre is listed from IC Thomson Reports, the world's most influential scientific minds from 2014. He has been awarded with an ERC Consolidator grant for the project, the highly efficient and reliable Smart Transformer HEART project, a new heart for the electric distribution system. He is member of different associations. He has been serving all these societies in different capacities. And also he received different medals and awards, especially the 2014 Bimal-K Bose Energy System Awards, in 2011 Industrial Electronics Magazine Best Paper Award, and the third prize paper award by the Industrial Power Converter Committee at ECCE 2012. And also he achieved the award and the 2000 Sustainable Energy System Technical Achievement Award and the 2018 Mittelmann Achievement Award. So this is a part of the resume of Professor Marco Liserre, and it's a really honor and pleasure to have you here. So it is, please welcome and start. Thank you very much, Marco.
Thank you very much for the nice introduction. I was changing browser because I have some problem with the other one. How can you hear my voice?
Yes, I can hear you. It is
okay, now I can also change with the new browser the headset. Okay, very nice. So that's fantastic. And then I can share the presentation. It's also, of course, a great pleasure to be today and give this presentation. Just 1 second, where it is. Okay, I can also share directly my screen. I think it's fine now. Yes.
Okay.
Yes.
Not
okay.
Yet.
Now you can see my screen, right?
Yes.
Yes, thank you.
Yeah. Okay, so that is the presentation title. You already very gently already saying, but I want to very briefly say where we are, who we are, and what we do. Of course, there was one of your professors that know us very well and was visiting us and had a very fruitful cooperation, but most of you don't know. And so let's just have a look here to that is the field of the of KIEL, which is one of the most most nice attraction of the city, with a lot of ships, typically in the best event of the city, which in the typically is done in June, but in the last 2 years is done in September for the well-known reason. Here you see a lot of ships sailing ships that are very nice. And so where we are, let me see. Okay, here, Kiel is the capital of the most Nordic Germany, or region of Germany. It's a sailing city. The Kieler Woche is the week of Kiel, is this event. I would ask you if definitely there are some microphone. They are still turned on. If you can turn off the microphone, I can speak better because I don't have in my ear all the noise. And also what is maybe more interesting for electrical engineers, there are two very important things. The fact that we have 8 gigawatt of wind energy, maybe we are, surely we are the energy, the region in the world with highest energy penetration of renewable energy in comparison to the consumed energy of the region. So this is a big challenge because you have to integrate 8 gigawatt of wind energy, which is of course varying quite a lot in a network which has been done for a much lower typical load in the order of a couple of gigawatt. And also this region is a power electronic region because we have north of Hamburg, here around a research center of Fraunhofer, which I will be joining in a few weeks to become a deputy director, and I will build in KIEL a new research center of this Fraunhofer Research Institution, which will be a large initiative, and we will create a co-institute in the University of KIEL of this Fraunhofer Research Center. And another reason is because we have also a lot of company in power electronics. There is Danfoss Power Electronics in Denmark, but also in Flensburg here in the north. So, I mean, we have a region with a strong vocation in the direction of power electronics. The university has been founded 350 years ago, and it has 2 clusters of excellence, 3 Nobel Prize, some famous scholars, which you may know, Hertz and Planck. The institute, the faculty to which I belong, has been one of the last one to be funded, but is very active. We have 3 institutes, and I would say apart Electrotechnic, electrical engineering, we have also material science, and we have also informatics. I am here at the chair from 8 years. Apart from this information that I show here, I want to share with you that in the last 2 years, I got professorship at the university, so Technical University of Ilmenau, Hamburg, and Munich, and I have refused all these offers to remain in Kiel and build a strong research group there. The team has 2 laboratories and is going to get a new laboratory, which I will briefly present very soon. One of the laboratories has, among the other, a strong focus about the grid integration of inverters. So we can do a lot of tests with testing different kind of control aspect with the real hardware inverter, so built inverter, and also with a system, a power supply, which is controlled by a real-time digital simulator to simulate a part of the system. We can also see the temperature of the device, of passive and active device with infrared camera, with the other measurement system. And then we have this new medium voltage laboratory, which has now in the cell 1 an MMC, modular multi-level converter, in the cell 2 a power converter based on silicon carbide, which can be used for charging station, and in cell 3 neutral point clamp and a T-type converter, which they circulate power. So a lot of prototypes. I hope that some of your students will have also interest to come to visit us, and I hope that when it will be possible to come soon to visit you. This is the new laboratory I was referring to, the laboratory about battery. In the figure you see also Sandra Hansen, who has been founding the laboratory with me. She's an expert in silicon battery, so we have very strong synergy with the material science people. And then we have so Mr. Gunther, who is actually the minister president of the region. So let's have a look now to the main reason of this research, or what has been actually convincing me that this is a topic which should be pursued. One of the starting point for me, one possible starting point, because we can see from different perspectives, is the so-called greater demand variability. And what you see here on the right side, on the top, is a figure which is coming from a study which is not particularly new. I would say that is also maybe more than 10 years old. This study shows that even without an high penetration of renewable energy and charging station, you see there are some curves that are on the bottom curves that respect to this curve they are a little bit higher, and these show a development in the basically in the recent year respect to the 80s, and show that the load of the network, the normalized load, is actually reduced for the number of hours which has been used. So basically the network is used in a worst way. So you have this peak power for which you have you see here with the peak power for which the network is used only for a very short time, and then the, let's say, most time the network is used with a lower load, and the integration of renewables and charging station will make the situation ever worse. That means that you have to increase the grid assets, the cable and the transformer, just to take care of the fact that for a short time you have a peak power. So it means that you are installing a lot of infrastructure that you will not really use it for most of the time. And then there are other things, of course, line congestion and voltage violation, which are also associated a lot to the presence of renewables. And then we ask ourselves, could be the smart transformer the solution? Yes, I think it can be. If we see the ways in which we try to create more flexibility in the electrical grid, and then to avoid or to reduce the need of reinforcement of the electrical grid to integrate more renewable energy, we do typically that, for example, with DC distribution. We do that using closing with a back-to-back the connection with another distribution line. We install STATCOM and storage, and if you have a smart transformer, you basically can do all these things with just one device. We can flexibly basically integrate most of the service which we have seen before. This is how the smart transformer can look like. It can be like 2, 3 stages. One stage can be done with classical 50 Hertz low frequency transformer, can be done integrating a high frequency transformer in the electronic. It's only theoretical things? No. I mean, this is a study which is actually a cost-benefit analysis made by a large company, which is Iberdrola. Scottish Power is a part of this large company, and they launched the project, and they made a cost-benefit analysis to justify this project. I did see the full presentation, but I cannot show the full presentation. I can only show this part, showing that basically integrating smart transformer and considering also the competitive technology, which I already show, the smart transformer can bring a lot of saving in terms of money and in terms of pollution. So what we want to do is actually to reinforce the actual grid assets. How we do that? We do that creating meshed networks. So the smart transformer allow to mesh the network in more points, and so allow to control the power flow better. And then, for example, this is a very simplified example of what I did show in terms of capability, and it's still a lot not really explored. Even if you have this simple configuration with a smart transformer, a storage here, and then another classical transformer, and you close this second switch here, then you can avoid voltage violation in most of the cases if you have high load or if you have high renewables. This is what we show here with 2 lines with the voltage range, and then we show that basically with the smart transformer in blue, we stay always between these 2 voltage limits. We can do also more. We can explore the so-called delta P capability of loads and distributed generation. This is a study that was done by some researcher in UK, Ballanti Ochoa, did highlight that we have in the grid a lot of loads which are voltage dependent. So if you change the voltage without the limit in which the voltage can change, then you can influence the load, which is so the power which is consumed by these loads. And the loads, they will not see the difference because typically the voltage is left fluctuating without a range, without to be controlled. But if you have the capability to control this voltage, you can use positively this actually capacity of the network. We did that in our laboratory, also testing with, you see here up the dependence of the loads on the voltage. This is described by this coefficient Kp, which basically tell you if you change the voltage, how the load is going to be influenced. And at a certain point, we say, okay, let's reduce the voltage, and we have some soft load shedding, 5% of reduction of the load. Can we, with these actually small change in the load, like compensate the imbalance between load production and consumption? Of course, we cannot do because it's very small, but we can do something which is very important. We can provide to our system, our power system, more damping. You may have heard that our power system with a lot of power electronics has not enough inertia. This is because we don't have the large synchronous machine. What we can do? We can emulate this inertia. That means we have to put storage, more cost, or you can also act a little bit on the damping. That is true that you have less inertia, but then when there is an undershoot or there is an overshoot, basically you are actually reducing this undershoot and overshoot. We made actually a simulation case in the network of Ireland with the University College of Dublin, and then we demonstrate that changing in this way the frequency nadir and the rock-off, we can basically have, as you see in the curve, which is here in red, much more extend the possible wind penetration. So that is a very practical result. Basically, you have a network which is much more dynamic because instead of having synchronous generator, you have power converter which they are connected wind turbine. Then this wind also has some variation, and this variation they create some perturbances, and then the oscillation of the because of these perturbances can make the system unstable, and we introduce, by changing the load, more damping into the system. So how we do that? We can do that, for example, building a 3-stage solid-state transformer, which is also a quite nice way to introduce you the technology of solid-state transformer. Solid-state transformer at the end is still something which has a classical transformer, but this transformer is an high-frequency transformer, and in this case, it is in the core of this DC-DC converter. And then you can have on the medium voltage side a medium voltage electronic, like this one, well-known modular multi-level converter, and in the low voltage side, typically you need a 4-wire system because you have to feed single-phase load. We have done some research and built prototypes. One of the most prestigious in our laboratory is this MMC, which is made in collaboration with ABB. We have built this cell, and we can go up to now 4 kilovolt, but we can easily reach also 11 kilowatt with the actual capacity of the cell that we have available. We have done some study about the modulation, considering the stress balancing of the different cell, because in modular architecture, there is the problem that is single submodules, they can tend to be differently stressed. And so by means of control, and in the case of power converter, you can do with modulation, you can try to make more equally loaded the cell, as you see here in green, and avoid that there is a big mismatch among the temperature of the different components, which can lead to early failure. We have been testing several possible DC-DC converter solution. This you see the point of some study in literature with power and efficiency. And then we have built our own with silicon carbide, reaching a very high efficiency, but still considering reliability in terms of fault tolerance and also lifetime consideration of the device. This is the prototype I did say about the series resonance converter, which we have here. but also we have been focusing quite a lot on a new topology, this quadruple active bridge, which is a multi-port topology, which is very suited to integrate a lot of different kind of sources, storage, and so on. This is a very nice study which show basically the cost and efficiency and the Pareto optimal surface, and then this is basically the best which we could realize, and we have built a prototype in this direction, so a little bit more expensive than a little bit more efficiency. These are some curves which show also the incredible jump you can do in this topology, moving from the silicon technology to the silicon carbide technology. And this is also, you see, this is the actual prototype that were built when we did start. So this topology was meant to have a very low efficiency. We pushed the efficiency quite high, considered it's a topology which offers a lot of controllability and connectivity. This is the new version of that. And we are focused also on the low voltage side inverter. There, the challenge is not really about building such a topology because it's classical topology, but it's a little bit the decision. 3-level inverter with connection between the capacitor, or to have, for example, 4-leg, and then also adding some extra feature like filtering, like this one, and modulation strategy. So actually, this figure shows some of the answer. With the common mode filter, you can, of course, reduce significantly, increase significantly the common mode impedance, and then reduce the common mode current. You have also to consider the common mode current, which is caused by the imbalance, not only by high frequency phenomena. So the problem is rather complex. Handling faults is also been a lot of focus of our research. We have been studying, okay, what's happened when one cell fails and then the system wants to continue to operate. But also in the grid, considering, for example, what happens if, for example, there is a fault in one load or up, or even up in this point, what the power converter should do. We have published, but also we have done a patent which recently has been awarded, so has been actually already given. What's happened when you have a fault and you lose one phase? With a smart transformer, you can continue to operate the system in 2 phases, and then you have to decide to make it to a 90-degree shift or 180-degree shift. In one case, you have a constant power, but you have a lot of current which is flowing in the neutral. In the other case, you have a lot of oscillation in the power, no current flowing in the neutral. But then we have also to consider the aspect related to reliability and availability of the system, because there is where the system operator, they are extremely concerned. If you talk with companies like Scottish Power or the group Iberdrola, then you understand, they ask themselves, what is the request in terms of maintenance? Will be always a smart transformer available, or it should be stopped for maintenance like a couple of days? For a distribution transformer, it's of course not possible. You should know that power electronics is, of course, demanding in terms of maintenance because of the fact that because the semiconductor which they are in the packaging, they are producing losses, and these losses, they produce some oscillation in the temperature, and this produce some mechanical stress in different points. We have been doing quite a work also in cooperation with the University of Wisconsin-Madison with Professor Lawrence, that unfortunately is not anymore with us, but he was really a pioneer in this field. We try to continue this research about also estimating the temperature of the device. So we did estimating the temperature of actually the semiconductor by collector emitter measurement. This was done with the university in South America, not too far away from you, I mean in Brazil, which we have also very good cooperation, but also we have some possibility to estimate the temperature inside the capacitor. And then what we do that we have proposed the revolutionary new method to control reliability, what is called power routing. So the basic of the power routing is that when the cell, they have differences because they have been, because of maintenance, replaced, or they are under slightly different condition, then you have to let flow different power through all these cells. This is basically what is happening in the balanced power case, and then we activate power routing. Some cells, they are the stronger, P2 and P3, they get more loaded. The weak one get less load, and then you can control the lifetime, which is incredible because we were habituated to control current, voltage, speed of our system, but we can also control the lifetime. We did this with very innovative methods, like, for example, using the third harmonics to actually create more imbalance among the voltages, because as you can notice, this is a system with serial cell and that the current is the same for each of the cell. And then this is, for example, some result for a specific mission profile. You see basically that with the power routing, there are one cell that was the weak one, which is extremely unloaded, and the other one, they are extremely more loaded. This is also something we did show in the laboratory to mean that also we have proven that we are able to control the temperature. And then we also make some statistical analysis to see what's happened with this power routing. And then we demonstrated with the power routing, we can extend the lifetime, and we can also increase the predictability of when some failure they will occur, because we consider the difference into the system and we adjust the loading of each of the parts of the system to have more predictability. So you see in blue, basically, that the variance became much smaller. So we know more or less that around 23 years, we have that the cell, most of the cell, they will fail, and then we can plan some maintenance. We have some conclusion here about actually the feature of the smart transformer. So if I have to sum up the challenge of the grid, I have to say that the biggest challenge of the grid is to handle a situation in which you have very uneven load into the grid, also in the space and in the time. So part of the grid are extremely loaded for short time, some other part of the grid are not loaded at all. And then you need to increase the controllability of the power flow. What you can do, you can create a meshed and hybrid grid connection. So you can also use DC grid. You can also use storage. You can have load dependent control. So you basically control the voltage and then you control the power as a consequence. But you can do also something more, like you can handle faults in an active way. So there are some extra features that you also has to be considered. Then how you build the smart transformer? You build with the let's say modular topology, which allows scalability and fault tolerance. But they may decrease reliability because you have more cells. How you handle the challenge of having so many cells? You can use the power routing. In the power routing, basically, you control the stress of the single cell, deciding where the power is flowing to allow to actually reduce the stress on those cells. They are more near to fail. Thank you very much for your attention, and I'm open to get some questions from you. Thank you.
Thank you very much, Dr. Liserre, by your kind presentation. Now we have, I think, one question here. Someone raised his hand. We are ready for your questions, please.
Okay, I have one question. I'd like to know if in this type of technology, the smart transformer, what you consider that is the most important challenge? The protections, the efficiency, the reliability, or you need to consider everything? That what is the most challenging for this kind of technology?
I would say that some years ago, when I did start my research, I point out two challenges. One was more known and the other one less known: efficiency and reliability. Efficiency, we could say that still is a challenge, but is more a technological challenge, not a scientific challenge, in the sense that efficiency can be increased with the new devices that we know, like silicon carbide. So efficiency can be still so subject of the research, but there we need the less important step forward. Reliability is still something, but not only reliability, also availability. So, for example, in the project that we have now, this project of Scottish Power, they plan to, in the pilot, to the grid, to have in parallel a traditional transformer, because they don't trust the actual power electronic transformer. And then this is where we have to make a step forward. So we have exactly to create a system which gain the the confidence of the system operator. We have to say that the smart transformers which have been built for let's say railway application, like the one of ABB, which has been very got top result, also was awarded as a milestone technology and so on. They have been running without faults for a lot of hours. But in the case of the transformer, that was for traction. So the train is sometimes getting stopped and you can do maintenance very frequently. In the case of a transformer, you have to consider something which is put in the field, and it should be for a lot of time remain without maintenance. So that, in my opinion, is the biggest challenge now.
Okay, thank you very much. And another question. You mentioned in your conclusions that a storage element could be an important consideration in this technology, but do you think that this is strictly necessary to consider the storage elements, or is it possible to work without these kind of elements in an application for distribution systems?
Well, this is a good question, because if we, I mean, the smart transformer introduce controllability, is also more expensive, and so one can ask himself, okay, but then if I add also the storage, will be the overall also too much expensive. So in my opinion, the storage should be limited in the case of using the smart transformer, and because you actually, the functionality, they have to bring some advantage. Maybe it should be distributed in the cell of the smart transformer, because then you can get a lot of advantage also in the case of failure, and it can be also used for other purpose for the power electronic itself.
Thank you.
Thank you. Dr. Agustin Ramirez from our institution asked, how important is the issue of control in the development of smart transformers?
Well, it is, in my opinion, also very interesting, and power electronics and control, they are coming together, like power system and control, from several years, I would say. In my opinion, has not been yet fully understood, both in the power electronic and power system community, the implication of putting such a device in a network. So, because typically they simulate in the network and leave the network as it is. So they don't consider to make meshed network. They don't consider to create more complex connection. So basically they are using a Ferrari, like a 500, the classical Fiat auto. So that is a Ferrari which has not been used. And when you consider to use the potential, then the control issues, they became a little bit demanding, because of course it should be also fast in the reaction, keep everything stable. And also internally in the power electronics, they have not been fully understood. Also, if you consider this challenge of the reliability, how much with the intelligence you can handle this kind of challenges without needing to oversight the system. So I would say absolutely top interesting.
Thank you. Now I let to Dr. Javier Diaz from our institution to ask his own question, please.
Thank you. Thank you, Professor Marco Liserre. It's a very interesting topic. My question is a more general question. Have your team worked with any applications of current digital electronic trends like IoT, cloud computing, deep learning in power electronics? Have you seen some kind of application of these technology trends in your area?
Not yet. I think I've seen some very, very early study because I think we also have to handle a large amount of data, and this will also has an impact into the the correct management of this data. So using also this let's say big data. I mean, it's not exactly my field, but I have the feeling that this kind of aspect they play an important role to again use at the top of the functionality of these, which is also work as a point to collect information. Okay, so this is absolutely important. Yeah.
Okay, thank you very much.
I see this question about available these technologies for the developed country. Actually, I have to say that I know that the power electronic transformer has been used quite a lot in countries where the network has some problems. I've been hearing about South Africa, also in India, and so on, because it's all about this at the hand. You have actually where there are some places where the network is not well developed, but it could be also, I mean, in the village nearby. I mean, we have between two villages we have not too much strong electricity network, and for example, we want to put light for the children. They come with a bicycle, and then they calculate, okay, if we want to bring the cable and so on, it costs an incredible amount of money. And then something, okay, but maybe I can do with DC with the light infrastructure, because I don't need to bring the full network. I may just need a very limited infrastructure that I can do. So I mean, low developed country for sure, but everywhere you need electricity, and you don't because the cost of installing a large network will be too expensive. Good.
Thank you, Doctor. Any other question, please? Oh, okay. I have another question. Okay, here in Latin America, what benefits can we have? Oh, I lost it. In Latin America, what benefits can we have with the smart transformers?
I think always has to do if you have some cases also in the north of Germany, and I think there are similar cases also in your case if you have some area which they are remote area far away from the main network, and then you also have maybe some development, but you don't know in 20 years, 30 years what will happen. Development also is sometimes is bringing a company after 20 years is not anymore producing something, but you have some software company. And then why you have to bring a very expensive infrastructure, which maybe in 20 years is not needed anymore. So it's about extending the actual network with the light infrastructure, which has low impact also on the ambient, and it's also cheap. And so it brings some flexibility at low cost. That is about smart transformer and DC, because that is one of the advantages of DC.
Okay. How is thank you. Rodrigo Angeles is a student from our institution. How do you see the interest of the European companies about invest in power electronics?
I mean, the interest of the company is very high. I mean, it's power electronics is a always growing field. It's amazing the growing of this market in Europe. It's only limited by the semiconductor they are missing. So this, as a concept, they are building also a large facility for producing silicon carbide, as it's also in USA, also is happening in China, and they are also looking for a new application. Because we have to say that a lot of push for this application of solid state transformer has been because of using silicon carbide devices. So I would say that the interest is quite high.
Okay, thank you. And finally, how this pandemic has affected to the investigation in Europe, especially in your group?
I would say that we have been lucky in the sense that in the North, Germany has been also some sometime like in Flensburg. I was mentioning Flensburg, where it's Danfoss is also a city on the border, and so there's a lot of people moving between Denmark, and so there will be some peak in there. They had some very strong lockdown. Where we are now, fortunately, we have been having less restrictions, so the laboratory was almost always open. Of course, we are still working with distance and so on, which make not easy to work also in the laboratory. One problem, of course, with the students, I think this was like in the rest of the world, and it's very bad for the students. We try to do the best to let them also a little bit stay in the laboratory, but was limited. And also the difficult to make new project, because sometimes you have to talk directly with the people. So I mean, from some point of view, we can say we have been lucky, but then also some of the problem of other part of the world we also get ourselves.
Okay, thank you so much, Dr. Liserre. I think that's all the questions.
Yes, I just want to ask something, or maybe that you let us know about the first part of your presentation. Maybe some people here are interested to go to KIEL and maybe visit to you and make a technical stay with you. So you can tell us about what they need to do in order to be with you there.
Well, I would say that the first things to do is to send me a letter, and better would be in the case of students if it's through your supervisor. So the professor which you are working with is always a very good introduction. And I relatively receive a lot of emails, so I would recommend that if you don't get answer, just ask Nimrod, because we have a good friendship relation. So if I got an email from him, I immediately notice. Sometimes I miss some email, and that is the first step to be done, and then we find a solution. If you really do you like to from one side to make an experience here, because we have this focus in power electronics, also a lot of materials, this Institute of Silicium Technology, and also, I mean, the nature is quite nice. Also to say the life is very, very calm, and is not so demanding to find an apartment, like for example in the city of Munich in south of Germany. Yeah.
Okay, thank you very much.
Yeah, I mean, the viability of the smart transformer in industry, I mean, the interest of the industry is quite high. There are large players like ABB. They are from time to time coming back to, now it's ABB Hitachi. They are giving attention from time to time back to this technology. So I'm saying that what I know, they are one of the top technology they are considering, and they are all looking for, there will be this outbreak and then really will take place. So, I mean, I think you make a good investment as student and researcher to go in this direction, because it's a technology which is booming in the next 5 years.
Okay, thank you very much, Professor Marco. I think that it's time to thank you, everybody. I think that this is joined your presentation and all your answer to the questions, and I think that is all. I don't know if someone wants to say something finally to finish the presentation and the conference, but if not, I think that this is all. Okay.
It was a pleasure for me. Thank you very much for the invitation, and I hope to have the possibility to come to visit you soon.
Yes, of course. I hope so.
Thank you.
Thank you very much, Professor.
Bye.
And thank you very much for attending, and muchas gracias. Creo que ya se desconectó el profesor. Tenía una reunión a las 10, por eso teníamos que terminar el tiempo, para que pudiera él conectarse a otra actividad. Y pues bueno, espero que les haya gustado la presentación y que haya sido de su interés esta presentación. Pues no sé si quiera comentar alguien los siguientes eventos que va a haber en el marco del 35 aniversario del programa de electrónica en el tecnológico. Sí.
Sí, gracias. Chicos, muchas gracias por atender a esta primera conferencia. Desafortunadamente, la plataforma nos impidió que se conectaran muchos más, pero les prometemos que para el miércoles esto estará solucionado. El próximo miércoles les recordamos que a las 12 del día también hay otra conferencia. Tenemos publicado el enlace por esta misma plataforma, pero vamos a ver, dado que sí tuvimos mucha demanda, vamos a ver de cambiarla a Teams o muy probablemente transmitirla en las dos plataformas, además de Facebook. Entonces, por favor, para que nos apoyen por ahí compartiéndolo. El viernes también tendremos un panel de egresados, pero como son egresados que están bien ocupados, tenemos problemas para ponernos de acuerdo en el horario. Entonces, en cuanto tengamos el horario, también se los haremos llegar. Por favor, publicítenos. Y pues bueno, hay que aprovechar que esta situación actual nos permite tener conferencias internacionales y nos permite interactuar con este tipo de personalidades. La conferencia el miércoles es en español, entonces para que no le teman tanto a las preguntas y demás. Entonces espero que esté tan o más interesante que esta. Muchas gracias a todos. Sí, Goretti, adelante, por favor. ¿Tienes algún comentario?
Sí, maestra, una pregunta. ¿La conferencia del miércoles la van a difundir por medio del correo institucional o por Facebook?
Lo hemos estado publicando por Facebook y mediante los profesores. Por ejemplo, de esta, ¿cómo te diste cuenta, Olga?
La maestra Fanny nos envió una invitación.
Ok, perfecto. Estuvimos tratando de que por medio del correo institucional se hiciera, pero como todavía estaban en periodo de aclaraciones, inscripciones de maestría y todo eso, creo que están un poquito saturados y no nos pudieron atender. Pero bueno, estamos haciendo todo lo posible por difundirlo por todos los medios, inclusive también a Comunicación y Difusión se les solicitó. Ojalá que ya por allí puedan publicar.